Hi everyone, my name is August Coles, and for my senior design project, I researched P3HT organic field effect transistors for biosensing application. My project was under the guidance of Dr. Leila Esfandiari in the Integrative Biosensing Laboratory. So currently, there's a great need and interest to analyze the health of individuals in a cost-effective and efficient manner. The detection of analytes in the body could lead to better understanding of diseases and ultimately lead to life-saving advancements. Here I report the use of a P3HT transistor to target the desired analytes for health monitoring and diagnostic systems. So a field effect transistor is a device which readily changes its conductance based on the accumulation of charge. These charge characters could be things such as biomolecules, which make an FET a promising device for detection since its change in conductance can be exploited. Because this particular device should be flexible and biocompatible, poly-3-hexaphenylene, known as P3HT, should be used over traditional silicon as a semiconductor within the device. And also P3HT is known to have high conductivity and hole mobility, which are important characteristics that make it a prime candidate for an FET sensor. So now that we have some background understanding and motivation of the device, I want to discuss my work throughout the 2 semesters. So my first semester of the research project was spent mostly understanding and researching key concepts that I would need to create the device. So things such as transducers, microfabrication techniques, as well as how to actually create and use the cleanroom facility were all research. This process, as noted by the Gantt chart, lasted until late October. Once this was complete, I began the fabrication process of the semiconductor, which is the most critical part of the device, and that began around November and December. So the methods and procedure are listed on the poster, but to give a high-level overview, the main technique that was used to fabricate the semiconductor was coaxial electrospinning. So in this process, we create nano-sized fibers of P3HT, which give particular characteristics that benefit the transistor's hole mobility. So the results on the poster show the SEM images of the fiber and that they are very high quality. So once this was complete, basic testing of the semiconductor was done. This included a conductivity test, as noted on the poster, and the results of this were comparable to that of the literature. This process took until about February, and then the remaining efforts of the fabrication were unfortunately cut short due to the pandemic, but there have still been other efforts made on behalf of the project. So most of this semester I've been working with my advisor to write a review paper about biosensing methods, which will hopefully be published this summer. I've also been working with her to write a proposal for the National Science Foundation for additional project funding to continue this research endeavor into the next years. So the proposal is to implant the device that I've discussed into a 3-dimensional cell culture called an organoid. And organoids are basically small versions of an organoid, and they mimic all of the organ properties that humans have. And they can be patient-specifically synthetically created. So you can take a patient's stem cells and then grow an organoid specifically for that patient. And that has implications in doing clinical drug testing for patient-specific medicine. So the idea for this research proposal is seen under the conclusions area of the poster. So as I continue working with this project into the summer, I'll be focusing mainly on finishing the fabrication of the device and then completing the device testing. And then we are also collaborating with Cincinnati Children's Hospital's custom groups, so that way the biosensing aspect can be further developed and researched. So thank you for visiting my webpage and listening to my presentation. If you have any concerns or comments or questions, visit the Contact Me page and feel free to send me an email. I hope you have a great rest of the day and enjoy the rest of the presentations.